Hey YouTube, welcome back. Today we're starting a new series, and this series we will talk about the core concepts of system design. I guess it will be like, I guess we have like 40 concepts that we will talk about in this series. And today we're starting by talking about the client server architecture, which is the backbone of modern software. So, what do your TikTok feed, online banking, and your favorite game of Fortnite, for example, all have in common? They all rely on the same fundamental pattern, the client server architecture. Stick around and you will walk away ready to whiteboard it and build it. But like, yeah, you will have the idea of how it works. Okay, so in our agenda today, we will cover the core concepts, how requests flow, the variations, scales, pitfalls, and best practices. So in the next minutes or 8 minutes, I don't know. I guess it will be between 8 to 10 minutes. We will break down what the client server patterns really is, how requests hops across the internet, the flavors you will meet in the wild, and the gotchas that trip up engineers during system design interviews. So let's roll. First, we will talk about the definition. So, at its core, let me take my pen. At its core, a client, let me make it thick. A client is any piece of software that consumes a service. Maybe it's your browser, a mobile app, even a command line crawl. A server is the program and usually a machine offering that service. They talk via a network, most often as TCP over IP, wrapped in higher level protocols like HTTP or gRPC. The big idea is separation of concerns. The client owns the server, the client owns the user experience, and the server owns the data and heavy lifting. Okay, let's go next to understand how the request flows. So, the client, basically, if you wanna get a single page, so a single page load triggers dozens of these conversations. So let's zoom into one. First, your client will resolve a DNS name to IP address. For example, google.com or facebook.com. And when the client sends the name to the DNS, the DNS will send back the IP address to the client. And once the IP address is obtained, it will try to make a connection or try to make HTTP requests to the server again. So your client resolves a DNS name to an IP, this by using a DNS service. Then the TCP handshakes establishes a reliable pipeline or a reliable pipe. If it's 2025, you better be using a TLS 1.3. The client fires an HTTP GET request. The server pulls from a cache or a database that data or that page, and it will serializes JSON and ships it back. And boom, you got your page. Boom, you got your response back. That's it. So when you make a request to get a page, there's dozens of requests happening in the background. Next, we will talk about why it scales or doesn't. So the beauty of this architecture, you can scale clients infinitely. They are on other people's hardware. Okay, servers though need horsepower. You will front them with a load balancer and stateless app instances, introduce caching layers like Redis, and shard or replicate your database. That's textbook interview material. Don't just say add more servers, and you need to describe the flow. Okay, so we will try to in this series we try to track each thing that we have said in the last 30 seconds. So we talk about load balancing, we talk about the bases, we do replication, we talk about shards, we talk about caching, we'll talk about all of that. So you'll find that most of the work we are doing in the servers, not in the client, because the client can scale infinitely because they are live in other people's machine. But in server, the servers are actually living in our machines. Okay, we can talk about some variations and real world example. There is thick vs thin clients. This one, desktop photos of Photoshop versus web Gmail, for example. There is 3 tier. It's basically web tier, app tier, database tier. It's a classic enterprise. There is microservices, which is many small servers. Each still speaks a client server over the network. There is also a serverless or API gateway. It's the clients talk to a gateway like lambdas using lambda functions and stuff like that. And lastly, we have a P2P twist. This is peer-to-peer. Like even peer-to-peer apps often put strap via discovery server. Maybe in the future we might talk about each one of them, specifically the microservices, because you will use them heavily in your system design interview. Okay, I guess next we will talk about the pros and cons of the client server architecture. First, the pros that we have a clear separation of UI versus business logic. Second, we scales on the server side, thin clients stay light. Okay, it's easier security control at the server. The cons is that we have a single point of failure. We need the redundancy. If we have one server and the server is gone, basically all of our data and or of business logic, we can't work with it anymore. Also, we face some network latency and offline issues. We might also have some costs problems on the back end, because if we wanna scale our system, we maybe buy more machines, add more infrastructure that could increase the cost and also could make our system more how can I say it? Yeah, more challenging to work with, or not that easy to work with, because when you scale your things up, you make it complicated. It's not that easy to understand what's going on. Lastly, I might talk about common pitfalls and best practice. I will talk about stateful services. So it's a session. If you have a session in RAM, like you need to say goodbye to horizontal scaling. You will use adjacent GW tokens or sticky sessions. Also, if we want to talk about over chatty APIs, like N+1 calls destroy mobile battery and latency. So you will use batch or use GraphQL. If you want to talk about security, validate every input, rate limit, and never trust the client. Like, never trust the client. The client is our enemy. Number 4, versioning, like break all the clients gracefully with V2 endpoints or content negotiation. And I guess we right now at the end of this video. So interviewers love to flip the script, your traffic, for example, just spiked 10 times more. What will be breaks first? Think through DNS, load balancer, server CPU, DB, database, IOPS, and cache hit rates. Next, I guess we might talk about load balancers. I do not remember, because I don't remember. What we'll talk about next? I don't remember. Okay, so that's it for this video, guys, and see you in the future.